Hi, everybody. My name is Cassidy, and I am part of Group 2. For our BST 635 final project, we decided to do PROC Lifetest. And like I said, my name is Cassidy, and the members of Group 2 are Monica, Meier, Lexee, and myself. For a little bit of background on PROC Lifetest and why we chose to do it for our group, we do have members from both a biostatistics background and a public health background. And so we thought this one was able to kind of pull from both things that our group members were interested in. PROC Lifetest is used to identify relationships between a response variable and independent variable or independent variables. What we're going to talk about in this presentation as a response variable is survival time, which we mean in saying survival time is the duration of time until death. And then independent variable or independent variables, these can be discrete, they can be continuous. Some examples might be age, sex, race, temperature, anything that you're looking at to see if that plays a role into duration of time until death. And so to run a PROC Lifetest, you need at least two variables, the response variable and at least one independent variable, but there can be multiple of those independent variables. What we're really looking for is to assess the dependence of the survival time variable on the response variable. So for example, how much does being a different age impact your duration of time until survival? As for output, it produces a non-parametric estimate of survival distribution, and this can be output in two different ways from that PROC Lifetest. You can have a survival curve, also better known as a Kaplan-Meier curve, and then you can have a life table, which is more an actuarial estimate of distribution. And so a table form or a curve form is what you can produce from this PROC Lifetest. And then before we get into the code a little bit, this is just kind of an example of why someone might use PROC Lifetest in a real life situation. This example is showing an epidemiological study that looks at uterine cancer by histological type. And what we want to say by this and just make the point is that epidemiological studies use PROC Lifetest and look at survival as a means to find what impacts survival. So they think if we can find those independent variables that we think haven't, or we see from this test have an impact on survival, then we can target those as clinicians and as a healthcare system and try to impact survival by targeting those independent variables that we discover through the use of this test.
Thank you, Cassidy, for the background. My name is Meier, and I'm going to walk through the dataset and the code. The dataset we used is the atherosclerosis risk in communities, or ERIC study. The data collection began in 1987 with 16,000 participants. Of them, 6,000 participants are still being followed up. So our dataset looks like this. It has more than 30 columns, but we used 6 columns for our analysis, which are race, gender, age, BMI, vital status like death, and the follow-up time. The default PROC Lifetest data will generate the Kaplan-Meier survival curve and the product estimate table, product limit estimate table. If we execute this code, we will see the table and the plot. So this table shows all the events that happen in terms of follow-up time. Until 171st unit of time, no event happened. And on 242nd unit of time, the second event happened. So if we go on like this, at the very end, we will see the last event happened at 9,166 unit of time. And here is the product life limit survival estimate. In our next slide, we show that we can actually filter this table, adding only the event points. So when we run this code, we will not see the non-event points anymore. We are only seeing the event points. And the plot will look a little different now because all these points are event points, so there is no other annotation. if we use the max time equals 2000, we can truncate the plot from the right side. There is no option available for plotting the curve for truncating from the left side. However, if we use the interval 8000 to 9000 option, we can actually see that in the table, we will only see the points from 8000 to 9000. And there's, we have to add one point, the first follow-up time and the first event, and the first follow-up time and the first event and the last follow-up time and the last event will always be listed. And here we are noticing that we have also stratified the plot in terms of gender. Okay, when we do that, we can also see that there are the summary of numbers, censored and uncensored values are listed here. Here we are stratifying the plot in terms of race. Similar tables are also outputted if we run the code. Here, this code is stratifying the plot in terms of BMI. BMI is a continuous variable, so we have categorized the variable between these zones. Our next project marker, lexee, will take it from here. Thank you.
Okay, so moving on to the next section of code for PROC Lifetest. So with PROC Lifetest, we can do confidence bands visualized on our plot here. So these are Hall-Welner confidence bands, just the type of 95% confidence interval. So when you produce a code and you get your confidence intervals, this is visualizing that, as you can see in several plots here. And the way you establish this is including this CB option. So CB is confidence band, and here we're doing equals Hall-Welner. So the HW test, the test option outputs a test for homogeneity, which is not included in here. It's not needed. So you can use the CB option in parentheses after your plots option to specify confidence band. You can also include numbers at risk tables. So on our left plot here, you can see that it has the number at risk for our sample by female and male at the bottom of the plot here. So again, you specify that in parentheses after your plots options. So here it looks like we still have Hall-Welner and our homogeneity test, but all you would need to do is use the at-risk option in this parenthesis. On the right here is specifying that we want our at-risk plot outside. So you just include at-risk outside, and then the 0.10 is the amount of space you're telling SAS to save for your at-risk table outside. We also have a hazard function that you can do with PROC Lifetest. So we're specifying plots as hazard here. So plots equals hazard is how you do this. And a hazard ratio is just like an odds ratio. So it's increased hazard of death. So you can do that for our whole sample here, or by stratum of male and female. And for this, they're followed up until death. So it looks a little funny for this particular data set, but you can look at hazard ratios as well. You can also define your bandwidth. So again, we're looking at hazard plots right here, and then also a survival plot to the left. And you just use the bandwidth statement in parentheses where you specify your at-risk statement. So bandwidth equals 1000 here, and we're looking at strata of BMI, so 15, 25, 35, 45 for our BMIs. And finally, we can also get our mean and median parameters for survival. So we have our quartile estimates here on the left, and then our mean follow-up time in this case before death is 8,170 months. So pretty long survival time for this particular cohort of heart patients.
As we heard earlier in this presentation, the life test procedure is can be used to look at survival analysis, also known as Kaplan-Meier. It examines the starting time from a defined point to the occurrence of a given event. Death is known as survival time, and the analysis of group data is known as survival analysis. Commonly used in pharmaceutical, epidemiological, and life sciences research. The Kaplan-Meier curve examines the probability of surviving in a given length of time while considering the time in many small intervals. It takes into account certain types of censored data, such as right censoring. This is when participants withdraw from the study or are lost to follow-up, or the event did not occur before the end of the study. These subjects should not be excluded from the analysis because they provide some important information about survival. The Kaplan-Meier method can be useful in generating evidence-based information on survival. The life test procedure can also produce life table estimates. These life tables display the probability that a person of a specific age will die before their next birthday, or the probability of death for each age group within a population. Life tables are useful for mortality rate projections and populations, but are typically created from recent past age-specific mortality rate data. There are two different types of life tables. One is the cohort life table. This demonstrates the overall mortality rates of a specific population's entire lifetime. It is used most often because it provides the ability to analyze patterns within mortality rate over a period of time. Period life table demonstrates the mortality rates of a specific time period for a specific population. Here is a comparison of the two different types of life tables. For the period life table, it is also known as a static life table, and it looks at a specific time period for a specific population, and it shows the current probability of death. The cohort life table, also known as generation life table, looks at the overall mortality rate of a specific population for their entire lifetime, and it looks at people born within a specific time period. In conclusion, the life test procedure is useful in the field of public health for measuring survival in regards to certain disease and for measuring the effect of treatments in improving years lived. The life test procedure can be stratified by numerous attributes of interest, such as gender, race, risk factors, and there is a wide range of publications that demonstrates the benefits of Kaplan-Meier and the life table analysis. Thank you.